Okay, since last time the part 4 we recorded was blurred. I don't know what happened to the camera, and the autofocus mode was off by itself, so we have to redo it. So let's redo it. But we remember the third part ended with, we introduced 5 out of 7 scientific base units, and then we already talked about currently very popular, almost every scientific textbook author, not 100% but 90-some% of the authors, they use a method to introduce the scientific base unit conversions, the process. It is called or named beautifully, very beautifully, as factor dash label unit cancellation method. And we discussed about this, and that method actually tried to eliminate the human brain function of you, the student, whoever is learning that method. The method tells you you don't have to have a brain. It's no-brainer, it's easy. If you want to convert any units from big to small or vice versa, from small to big, you just need to know the conversion factors. They didn't even specify that conversion factor is no longer the textbook style, but it's a per concept, like my introduction of conversion factors just in a few minutes. We already mentioned that in the discussion, but they say, okay, you just plug in. They give you a grid, right? Remember grid, G-R-I-D, and one line, one horizontal line, and then a couple vertical lines, and in between each vertical line, there will be a space up and down the numerator position and the denominator position for you to plug in the conversion factors. But they told you you have to flip sometimes, but they did not tell you when, at what condition you have to flip. And then the student was in the clouds, so confused, and they just plug in. They thought it was correct, but sometimes, as I observed, most of the times, not even multiple steps of conversion, but 2 or 3 steps of conversion, they already start to make a bit mistake. They plug in wrong, and they didn't pay attention to cancellation of unwanted units and try to keep the wanted units. So keep on moving, because that method claims you don't need to use your brain, but you can just plug in that grid. You can always convert a huge number of small units to big units. One step, straightforward, 1, 2, 3, 4, and use that grid. Never gone wrong. But actually, most of my students, as I have seen, they gone wrong, right? So that is a method. Try to eliminate your human brain function. You don't have to use your brain, they say. That is terrible. That's my point. How dare they invent such a method trying to eliminate your human brain function? That's bad. It's rotten, and it's not working. So we talked about this. So we did that. And we criticized, actually I would have to say, it's called SCOLD. S-C-O-L-D. SCOLD, that kind of method, alright? So then we introduced 7 basic units with 5, both English and the metric system, we did that. And then we discussed the unit conversion factors, right? Listed, right? In the textbook, almost every textbook will give you a list. Either at the time they talk about the scientific conversion units, or they talk about scientific units, and then or sometimes, most of the time, each textbook will have 1 page, either front hard copy page right here. This is chemistry book. This is the most useful and best general chemistry book written by Peter Atkins. But in the back of his book, they give you a list of conversion factors, but not just what we are talking about here. They have more, right? So, but in either case, those textbook style conversion factors cannot be directly applied into conversion equations during the process of conversion, right? So you have to transform this kind of conversion factor into the price tag format, or I call the per concept style, and then you are able to plug in. So that's what we talked about already. We did that. So because that textbook style cannot be used in the conversion process, cannot be directly used in conversion process, right here. And then we introduce the price tag style of the unit conversion factors, and that is what is that? That is our common sense, already familiar with, right? If you recall, last week's one of the sections of our last week lecture, we we discussed a problem about buy a watermelon. You have a $30, right, in your hand, and then you went to Walmart and you want to buy a watermelon to have a watermelon party, inviting your friends, your buddies, and come to have a hot summer, cold, ice cold watermelon party. And that time, and the watermelon price at Walmart was $2.99 a piece. And the question is, how many pieces of watermelon your $30 can buy if that was just the same, it hit the same day we call tax-free day. You don't pay tax. And my response, the response from my students, when we do Zoom, right? We do Zoom lecturing, and then they say, well, 10. Now first I saw one student says 90, I don't know where 90 come from, but, and then I said, what, 90? And then she's immediately changed, oh no, 10. She texted on the chat room. I said, that's right, 10 is correct. Then I asked her, how did you end up with 10? End up with 10 correct answer. Is it multiplication or division? She said division. See? That's her, even she made a small mistake at the beginning, but she knew she was doing division, not multiplication. But not multiplication, as this rotten factor label unit cancellation tells you, you only need to know how to multiply, because the grid, what is the grid? The grid looks like that. I'm going to erase it. Grid like this, right? You say, okay, 10 miles or 10 kilometer and equal how many mile, right? And then they give you grid, right? Or 10 meter, 10. Let's just put 100 meter. How many miles? They want you to plug in there. And in between each column, they want you to multiply only. That cross is a multiplication symbol. And she said, no, it's not, because we have to deal with two situations. What are these two situations? You're going to face two situations. In the same entity of scientific base unit, say lengths, you don't convert lengths to mass, or vice versa, mass to time, or time to mass. They are not related, right? They are not in the same category. They are not the same entity in scientific units. You cannot mix them and convert them. There's no relation between them. That's the first point you have to make. You have to understand that. Then secondly, if you are in the same entity, you need to know which direction you convert to. That's the two situations you run into. Which two? You convert from big scale of the same lengths, same entity, to the smaller one, or vice versa, from smaller units to the bigger one. So it not always involves multiplication only. It involves division. So that's my tips, capitalized TIPS. It's coming, right? And already in my notes. And then you use that tips to start with, and then identify which way we go, which one's big units, which one's smaller units, and which one we go, and which method we use, which mathematical operation method, which means is multiplication or is division. You have to choose that, and then you use the fraction style set up, and then you go reciprocate. Now that's my tips. I don't want everybody to do multiple conversions. I want you to do one conversion at a time, or one step at a time. Guarantee each step is correct, and then move on to the second one. I don't tell you my method can convert 1,000 steps in one shot. No, it's not going to work, right? Because you may make a mistake. Too many, you don't check the final results, right? And then at the end, and you have so many middle, intermediate results you've gone through, and may have one step wrong, and everything's wasted time to end up wrong answer. So one at a time. So that is Rotten method. It's not always multiplication. Sometimes here involve division, maybe division down there. So that's what I'm talking about. You need to know which way you go. Now, so in this case, right? And but we have first to convert the textbook style conversion factor into a price tag style or per concept, what I call per concept format, all right? And then we use that conversion factor to do the converging steps. So now, let's see if we have time. Yes, we do. And we have, let's list all these 5 price tag or per concept basis unit converging factors for lengths and the mass. All right, let's do that. All right. So let's see, the first one, let's say the category is lengths. Lengths. Now in lengths, right, we already introduced, in this category, we do have English system, right, bothers everybody. If you want to learn science, because science uses metric system. So you have to know some kind of converting factor between the metric system and the English system, or vice versa. For most of our students, right, born, raised in this country, dealing with the English system, lengths, units, and mass units in English system, the most important steps try to get you set up straight how to convert English system into metric system correctly, right? So for this, we say, okay, we have English system, right, to metric system, right, to metric system, right? So how many we have? We have 2 also. That's the length. You know, what are the other 2? One's a bigger one. I want you to memorize, you know, out of many. And so we have how many? We have the first one is the large scale we dealing with. It's the large scale. Large scale in lengths. So what is the large scale conversion? Between miles and kilometer, because a mile and a kilometer is kind of close scale-wise, right? Kind of close. Even miles 1.6 times greater lengths than the kilometer. So in the textbook says 1 mile equal 1 point, now let me make this big, this is a decimal point right here. 1.609 kilometer. But that's textbook style. We don't use that in converting process. We give you a price tag. So price tag, normally price tag is printed on a little piece of paper, right? A little piece of paper like this paper, and then says, okay, and 1.6 mile or 1.6 kilometer / per mile, right? So that's what happens. So we're going to use that 1.609 kilometer, right? This is print, and it is italic, and it's mile. Now that is mile shorthand, mi, right? And then I am gonna box it for you to memorize this one. I want you to memorize this one, this first one, all right? There's 4 more to go. Now, not too many. Then there's a larger scale. What is the next one in the English metric system conversion, right? It's a smaller scale, the smaller scale. Small scale, what do we talk about? Inch. So in English system, inch is, right, smaller than mile, right? And then equal how many centimeter? Because inch is about this big, right? Centimeter is about 2.5 times smaller than that. It's about this big, right? So 2.54 centimeter. Still, this is a textbook style converting factor, you cannot use it directly into process of conversion. So we need you to remember this in the boxed up case, right? So 2.54 centimeter per IN. That stands for inch. Let me use a box to box this up also. I'll make a smaller box. Smaller box representing a length smaller scale converting factor in per concept or price tag style. Alright, that's the one you use. Now that's the length, right? And then beyond that, the metric going back. We don't want to introduce anything going back, say 1 kilometer equal how many miles? You don't need that. We always can convert in between and use these two. We'll show you either multiplication or division, and we are able to handle that. Right? So now the next one is another category, right? Mass. In mass, right? We also have to deal with the metric and English system conversions, right? And unfortunately, right? So in the mass, we start from 1, right? In the same order from English to metrics, and then we have to introduce one more, which is number 5, for you to memorize. Is from metric to English. Now the first one, right? Say English. See enough. English to metric system, right? Go by the same trend. Go first, we go large scale, then we go smaller scale. Now what is large scale for English for mass? That's 1 pound, right? We normally use pound for regular stuff. We talk pound, right? So go by the same, say large scale, right? So 1 pound equal how many gram? Now go check the list in your textbook, which we don't use. I said in my class we use my notes, right? About 40 some pages. And it's going to be 453 gram 453.59 gram. Okay, now I have to write this one in this, so it's not entirely, it's plain a G, right? It's not kg because in this case it's smaller, 1,000 times of this standard base unit, and then that is textbook style, right? And then this time again, we cannot directly use this conversion factor because the equal sign is in the middle. We cannot have an equation with 2 equal sign, right? So then we have to have a boxed format. Let's use this. So it's going to be 453.59 gram per what? Pound. Now this time, right, this is going to be number 3 of the conversion factor in price tag style. Oops, my hand accidentally removed the corner. Now these 3. Now that's large scale. Then the smaller scale, right? Small scale. We talk about ounce, the regular ounce. On my notes, I said there's so many, 4, right? We mentioned there's 4 different type of ounce in English system, which is so confused, right? 3 of 4 were representing mass. 1 is not even touching anything related to the mass, but for the volume. That's called fluid ions, right? We already mentioned that. Check my notes. You all received my email, right? You all should print out 1 copy, but if you don't, that's fine. We will give you on the lecture as well, on the Zoom lecture as well as this YouTube, you are able to watch. So when regular ounce, if you don't think you are able to memorize this, then I'm going to put down there a subscript. REG, representing regular, means not precious metal, not troy ounce, right? So regular, right, subscript. 1 OZ reg, and then it's equal 28.35 gram per regular ounce. But as I said and repeated so many times for all these four, we say this is a textbook style conversion factor, unit conversion factor. We cannot use it in the process of a conversion, and we have to change into a price tag or per concept based conversion units. So again, we will have this boxed. Let me put a little bit on the right hand side. So it's going to be 28.35 gram line, horizontal line per what? Per ounce. Now in case you forget, you make per reg. And then this is going to be the number 4 converting factor. I want you to memorize these 4. Last one. These two is for links converting from English system units to metric system units, right? Both. But then I'll give you one more. All right, because mass the base unit, standard base unit for mass in the metric system is not gram, it's a kilogram. So we may have to list this as one important conversion factor for you to memorize, which is going to reverse the order. So, and they say A, and then say B, right? B from metric to English. All right. Now this time is going to be the large scale, not small scale, but only one. I don't have 1 and 2, so just the large scale. What is large scale? Pounds, at least, right? We talk pound. So large scale in the textbook, you will have this one. It says 1 kilogram equals 2.205 pounds. So in textbook, 1 kilogram equivalence. Now equal is not the correct term. You can say that on the number scale equal, but actually this is how much stuff equivalence, how much stuff in another scale, right? Another unit, which is English in the metric. So it's going to be what? 2.205 what? Pound. Now since it is not a per style for you to do conversion directly, so we're gonna have to write this textbook style conversion factor into a per concept, the per concept based style in the box. So what is that? That's 1 kilo equivalent to 2.205 pound, then 2.205 pound per kilo. So 2.205 pounds, right, per a line fraction, right, per kilo, right, grams. Now that is also big scale, but it's between the order of metric converting to English. Now those five. Now we're going to use those 5 in the next 30-minute section to give you exercises, right? But here we still got 5 minutes left. Now that links and the mass. There's something I already put into the course notes for my chemistry class, and I just thought about it yesterday. I did not even because I thought my mind thought, well, we all understood. No, this is not necessarily everybody, right? So I probably have to throw it in, so nobody gonna miss that part if you didn't pay attention to this. It's time. The time scale, right? We talked about 7 base units, right? Scientific base units. We made 7 of them. The first one links and the mass, and then time and temperature, right? and the amount of substances we call mole, M-O-L-E, and then the electric current, right, called ampere, right, and then the luminous intensity, which is the light's intensity, we call candela, right? So those, but last two we don't involve it, we just introduce it, and then we don't discuss them. The first five, number 3 is what? Number 3 is time. And then we already on my notes, I said that time is easy. No, it's not necessary for everybody. I suddenly realized yesterday, because the standard time scale we set up as second for both English and the metric system seemed to be easier for us to handle, because we've been dealing with seconds all our life. But we know between seconds and hour and the minutes and hours, they both were 60-60 advanced, right? 60 seconds will be 1 minute, 60 minutes will be 1 second. But we only had some problem in the student body. They consider 1 hour is going to be 360 seconds. Run into this kind of situation quite often, right? Because you are not a science major. Even your science major, the number did not go through your mind when you answer that question carefully, and it says 360. But the 60 times 60, 6 times 6 is 36, and got 2 zeros, that's going to be 3600, 3600, right? So that's a mistake. 1 zero less, so your time is faster. That's one point I want to point out. But beyond that, I thought everybody should, but think about the majority of students are not science major. And they may miss. We do have the scale for time go beyond seconds, bigger, always 60-60. No, it's not, right? It's not like a 60-hour will be what? 1 day. So that is so chaotic. So 60 from 60 seconds to 1 minute. And then 60 minutes will be 1 hour. Is that 6 hour 1 day? No, they change it to 24 hour a day, which is not really 24. In reality, the Earth's spin self-rotation around its axis is only take 23 hours, 56 minutes, and 4 seconds. Got some minutes short, right? Some minutes missing, almost 4 minutes missing. And then in a 1 year or 4 year time, will accumulate into 1 more day. That is going to be, we call it leap day. Now in this Western calendar or Caesar's calendar, we apply that day in what? In February, either 28 or February 29. I think this year is a leap year, right? So we have 29 on February already passed, right? But it's not 60, it's 24 even we use. And then is that 24 day a year? No, it's not. Is a 60 day a year? No, it's not. It's what? It's 365.2 days a year. But the 0.2 come from the every year. Every day is not 24 hours exactly, right? So that's chaotic. That's look like it's English system style conversion, right? But what happened underneath 1 second? It's not beyond 1 second. If any scale smaller than 1 second, that is very strange. I just thought about yesterday. I must introduce that. So basically, the third category is going to be time, right? Time, and basically the big one, right? So you talk about between English and metric system, we all the same was based on second, right? So we have to know this is 1 minute equals 60 seconds. So you have something as per style 60 seconds per minute, right? You know that, so I don't have to ask you to memorize that, right? That's one. And then you have another one is 1 hour equal, we already talked about 3,600 seconds, right? And then you don't use that directly, you have to convert it to the per, so the 30, that's common right here, right? 6